Alright, so we're going to go ahead and discuss radians once more, and go ahead and start working on converting radians between radians and degrees. So what I want to do is just go back over sort of what we were talking about with how we will define an angle in terms of radians. And so if I have this angle here, and the special thing about this angle is that it just so happens that this circle has a radius of r, and the arc length here is also r. And this arc length, this arc subtends this angle theta. We say the arc subtends theta. And that just means, right, that it is the arc length which sort of closes the angle, or that runs along the circle from the first ray of the angle to the second ray, if we think about the angle having these two rays that go out on either side. And so radians, right, the word radians is just very, very similar. It's a variation of the word radius. And the best way that we can describe this angle theta is that it has covered one full radius in its arc length. Okay? And so this angle, we will say this angle theta is equal to 1 radian. And I want to just talk really briefly again why that is. It has traveled, the arc length that subtends this angle, or that closes this angle, is exactly 1 radius long. And so when we're saying that theta is 1 radian, we're talking about the length of the arc in relationship to the radius. It's exactly 1 radius long. Okay, now let's take a look at another example, and let's think about the angle theta which goes all the way around. So this is the 360 degree angle. And we want to think about what would the number of radians, or the radian measure of this angle theta be. So I want you to pause the video and just work it out yourself, think through it, and then go ahead and press play and we'll discuss. So if you go back, remember we just talked about radians. Radian is the number of radiuses in the arc length that closes the angle. So in this case, the angle here, well, the arc length is all the way around. So in order to figure this out, right, and so I have my radius r here, I need to know, well, what is this arc length that goes all the way around? And that's just the circumference, which is 2 times pi times r. And so think for a second, you might want to pause here, how many radiuses make up this arc length for my angle theta? Well, it's a simple question. If I have a total arc length of 2 times pi times r, and I want to know how many radiuses are in that, I'm simply going to take the arc length and divide it by the radius. And so I have 2 pi radians. 2 pi radians. And so what we kind of notice here, if we look at both of these examples, is that it doesn't matter what the radius is. For example, if I look here, if I had a much bigger circle, it would not matter what the radius was, because I'm only comparing the circumference and the radius. And if I make the circle bigger, the radius gets bigger, but so does the circumference. And so I'll still be left with 2 pi. So this is interesting, and this is important to note, is that 2 pi is exactly 360 degrees. So now we can kind of take a look at the general case. And so if I have any circle here, and I'm looking at any angle theta, and the radius is r, and I have some arc length, and I don't know what this is, right? I'm looking at the general situation, so for any angle theta. So let's just go ahead and say that this arc length was given by the variable s. Well, then the angle theta is how many radians? I want to know how many radiuses are in my arc length. And so theta is simply going to be the arc length s divided by the radius r. And we should make that arc length green. So once more, the number of radians, the measure of an angle in radians, is how many radiuses make up the arc length, which we say subtends theta or closes theta. And that is s divided by r, the arc length divided by the radius. But it's important to remember now that does it matter how big my circle is? Does it matter what the radius is? And we just talked about when I make my radius bigger, the arc length also gets bigger. So if I were to make this circle bigger, I'll just sort of sketch it out. Imagine it were bigger. We're a bigger circle. Well, then the radius would be larger, but so would the arc length. And since I'm just looking at the ratio between the two, as we saw in this example over here, it doesn't matter. The angle will always be the same. And so I can choose what I want my circle, what my radius to be. I can pick the easiest circle possible. I can say, let's just look at a circle with radius 1. And so when I choose the radius to be 1, this r becomes 1. And so the angle theta just ends up being the arc length that subtends the angle of a circle with radius 1. And a circle with radius 1 is what we call a unit circle. So now we can have this firm definition as to how we find the radian measure of any angle. So if you give me an angle theta, I subscribe it in a circle with radius 1, and then I'm just measuring the arc length. And that is going to be the radian measure. I can put RAD for radians here. So let's take a look at the definition. The radian measure of an angle, theta, so for any angle, is the length of an arc, we just talked about that, on a unit circle, meaning that the radius is 1, subtended by the angle. So let's read that one more time. The radian measure of an angle is the length of the arc on the unit circle subtended by the angle. That's this right here. This is the arc that subtends the angle because it closes that angle. And so we can just look at a unit circle with this degree measure and we can find the arc length. And now we have to include this one key piece of information that we found, which was when we looked at a full 360 degree angle, we found that that was 2 pi radians. So what I want you to do right now is, using this fact, I want you to go ahead and begin converting. Find 1 degree in terms of radians and 1 radian in terms of degrees. I want you to split your paper in half. And so on the left side, find degree in radians, and on the right side, find 1 radian in terms of degrees. All right, I hope that went well. What you can notice here is that you can just use this fact that 360 degrees is equal to 2 pi radians. And so if I want to know what 1 degree is in terms of radians, I can divide by 360 on both sides. And I will end up with 1 degree being equivalent to, these cancel, so 2 over 360 is just 180. And I'm left with pi over 180 radians. We want to keep it in terms of pi because pi is an irrational number, so we want to be as precise as possible, so we leave it in terms of pi. Now on the other side, and I encourage you to pause and try this again if you haven't already, we want to know what 1 radian is equivalent to. So I start with 360 degrees is equivalent to 2 pi radians. And what I can do is I can just divide by 2 pi on both sides. And so now I have that 1 radian is equivalent, and 360 divided by 2 is 180, 180 over pi degrees. use that to go ahead and convert a couple of measures. So say you had 60 degrees, convert that to radians. Take 2 pi, and this should be radians here, pi over 2 radians, and convert that to degrees. And then this last question here asks you to think about the minute hand of a clock. So this one, you might want to draw out a picture for yourself and really represent it visually in order to help you solve it. And make sure you write down any questions or concerns if you have any.